This is problem number 44 on chapter 5.8. And it says, a cylinder is inscribed in a sphere of radius 8. Write an equation for the volume of the cylinder as a function of h, that's the height of the cylinder. Find the value of h, that's the height of the cylinder, that maximizes the volume of the inscribed cylinder. That's an interesting problem. What is the maximum volume of the cylinder? So we have an interesting problem here. And when I first looked at it, the first thing that kind of came to mind was, let me shrink this here, was the, I thought, well, you know, I know that the volume of a cylinder, V, is equal to 4/3 pi r cubed. And as it turns out, that is actually irrelevant to this problem. I don't really need to know the volume of the cylinder. What I do need to know is that the volume of the cylinder is going to be pi r squared h. That is equal to the volume of the cylinder. That's because I have the, pi r squared is the area of my base, and h is the height. So that's going to be the volume of my cylinder. And that's really all that I need to know here. Except what this is giving me from the volume of the cylinder is it's giving me that the distance from the very center of the sphere, which would also be the center of the cylinder, which is inscribed in the sphere, from the center out to the edge here is 8. And what that tells me is that by using the Pythagorean theorem, I can kind of see if I can draw here. Oh, I can. I can figure out this right triangle right there. So I can actually use that to find out what is the radius of my cylinder, which is going to be different than the radius of the sphere. So I know, using the Pythagorean theorem, that 8 squared is going to be equal to my r squared plus 1/2 of my height squared. So I have c squared is equal to a squared, which is my radius, times plus b squared, which is 1/2 the distance from the bottom of the cylinder to the middle of the cylinder, which takes me to the middle of the sphere. So I can do that with the Pythagorean theorem. And knowing that, then I can begin to kind of work out the mathematics of this problem. So I get 64 is equal to r squared plus h squared over 4. Or, kind of putting my, because I want to solve for r, I can have my r squared is equal to 64 minus h squared over 4. Well, let's do something fancy here and change the color of the pen. Let's go to red. And let's take the square root of both sides of this equation. So now I'm going to have my r is equal to the square root of 64 minus h squared over 4. Let's make that look a little bit more like an h. Okay, so I know I could simplify that since I have the difference of two perfect squares. Well, actually, I couldn't simplify it because it's the difference of two perfect squares, which doesn't really help me with my with the square root. So let's kind of keep on going here. Let's go and try a different color pen. Let's go to blue. Okay, so the volume of my cylinder, the volume of the cylinder is equal to pi r squared h, which is the same thing as saying it's equal to pi times, let's put it in parentheses, the square root of 64 minus h squared over 4 squared. You see I just substituted my r here for my r there times h. Work a little bit more math here. I give myself a little bit more room. So since I have the square of a square root, that's going to equal pi times 64 minus h squared over 4 times h. Which is equal to h pi, I'm just moving my h over, 64 minus h squared over 4. So that's what my volume is equal to. Now let's just pause this for a second while I get the calculator up so you don't have to watch me do that. Okay, so what I did now was I put on the calculator this this formula here. Of course, I had to use x instead of h, but I have x times pi times parentheses 64 minus x squared divided by 4. I put that in parentheses, and then I have a second parentheses to make sure that it's multiplying the whole thing times the x times pi. And what I did then was I went zoom 6. And I can see over here that it's working, and nothing happens. I don't have anything on my graph. Well, why is that? That's a little bit disturbing to me. Well, partly it's because my graph, when I do zoom 6, I'm getting kind of like the origin is the middle, and I'm getting y from like -10 to +10, x from -10 to +10. And I can see by looking at my formula that my numbers are going to be a lot different than that. I mean, I know that the radius of the sphere is 8, and I can see, even though my radius of my cylinder is going to be less than that, I can see that my height is going to be a cubic function. I'm going to have h and then times h squared, so h cubed. So that's going to be a much larger thing. But I also know that my my x value, which is going to be my height, and my y value, which is going to be my volume, that my x value isn't going to be that big because the radius is only going to be, the radius of the sphere is only 8. So what I did was I kind of took this information and I went into my window and I changed things. I said, well, let's make my x minimum. First, my x minimum is going to be 0 because I can't get any distance less than 0 for the height. And my x maximum, I made it 16. And I left the scale at 1. And then I went to my y minimum. Well, again, my y minimum, the lowest it can possibly be is 0. The lowest volume I can possibly have is 0. But the y maximum was a little bit more tricky because I figured, well, I'm looking for the volume of the cylinder. I know that the radius of the sphere is 8. I know that it's not going to be 8 cubed, but I thought, well, 8 cubed, that might be a big number. I actually went to 16 cubed since I knew that I just kind of doubled it. So 16 cubed is 4,096. So that's what I used for my y maximum, was 4096. And for my scale, since I didn't want it to be too compressed, I used 400. So every notch is worth 400. And then I pressed graph. And lo and behold, now I have a much nicer, much more manageable picture of my function here. And my function is volume as a function of height. So what I want to find to answer the question is going to be, well, what is the maximum value that I have in this function? So I'm going to go second, calc. I want to find my maximum, 4. So my left bound, well, that looks like it's a little bit. I'll go a little bit more to the left just to be safe here, and I'll put that for my left bound, and I'll kind of glide it over here past the little hump, get to my right bound. Let's get a right bound there. Okay, it looks like it's past the hump, even a little bit more there. Okay, and I go enter. No, I don't want to make a guess. And what it tells me is that my maximum is, my height is going to be 9.23 or 9.24, and the maximum volume that's going to give me is 1,238. So that's the answer to this problem.